Methods, we're going to look at question 7, 8, and 10. Okay, so for question 7, we've got iodine, it's going to decay. We start off 1 unit, and the isotope's reduced to 0.9174 T units, obviously to power T units. So how many days does it take for the iodine to fall less than zero point 0.2 units? Okay, so really simple. What scenario is, you're starting at 1 unit, it's decaying exponentially, and you're just trying to find when it goes below 2 units. So just trying to find that T when that happens. So you're going to use the model y equals a times b to t. That's our base case model. Now I know my a is going to be 1, so, and 1 times anything is just that thing, times, now the base they've given you, 9174, is the power t. You just try to find when it equals, when that point happens, like when the function, or the equation, equals 0.2. So let's see when that happens. So I'm going to go type that in, 0.2 equals, I don't even need the 1, because 1 times anything is just the same thing. So power x, I'm going to go interactive advanced solve. And as you can see, after 18.668 days, so when t is greater than 18.668 days, if you're rounding it, then you'll go t is greater than 19 days. I'm not sure what the book rounds it to, but we know that when t equals 18.668 days, any value above that, like any days above that value, then we know the iodine level would be below 0.2, okay, which is what the question's asking. If we look at question 10, we've got, no, question 8, sorry. We've got two populations, P and Q, okay, and T is the number of years since 1950. And that's important because when we're writing an answer, we have to know what our T0 represents. T0 represents 1950, and T is the number of years. So we just want to plot the graph by functions using the calculator. So I'm going to type this into our main screen. Now, remember, you don't need Y to drag and drop. I'm just going to drag them. Now, whenever you're entering in powers, make sure you put brackets in because the calculator misinterprets. So I'm going to type both of them on the same line. I just need to drag and drop the right one. 0.04 x. Now I'm gonna plot this on, and I'm gonna plot this on. Now the graph's not really showing properly, so you've got to look for clues in which to help you draw the graph. It says over a period of 50 years from 1950. So your x value, which is your t, which should be from 0 to 50, but I'm going to go 0 to 100 just to show more of it, okay? And my y scale, I might want to go from 0 to, let's say, 100. Okay, perfect. It shows the graph really well. Now, you're just going to plot these two graphs on the CAS calculator. Now, if you look at the y-intercept, then you know that that's 1.2 and 1.7. You should be able to know that as from your experience solving equations. You're trying to find when the populations are equal, so just go analysis, G solve, intersection. It equals at 12.56 after 12.56 years. Now, you got to be careful. I'm assuming whenever you're doing like exponential, you usually round up, okay, because they don't really equal at 12 years time. It's more the 13th year. So 13 years after 1950 is 1963. So I'll answer with 1963. Now the second part's tricky. Find when the population of P is twice the population of Q. So you just to solve this, you go 2 times Q equals P. Okay, so 2 times Q, so I'm multiplying Q by 2, and we're letting it equal P. So I'm just going to put an equal sign there because I've already typed in the two equations from the previous graph, from previously like trying to draw a graph on the calculator. So go interactive advanced solve X. So 37 years. I'll round up to 38 years. So it will happen in the year 1988. Okay, 1988. That's when the population of P will be twice that of the population of Q. Let's go to the next question. Question 10. So we've got 5 kilograms of sugar dissolved in water after 2 hours. The amount of S kilograms of sugar dissolved is given by this. Okay, great. That makes sense because initially it's 5. That's why the 5 there. We're wanting to find what K equals to. Okay, so just sub in what you know and just solve for the unknown. Okay, so we know S is 3.2. When S is 3.2, T equals 2. So 5 10 to the power. Now we're trying to solve for K, I believe. So I'm just going to call that X times 2 because we know T is 2. Interactive and solve for X. Okay, and that's that. Okay, and you notice our K value is negative, which no, it's actually positive. Let me see. Oops, I've got to be careful. Okay, our K value is positive because I forgot the negative sign. Now, what time would there be 1 kilogram sugar remaining? Okay, so we've got our model. Our model is 5 times, 5 times 10 to the power of negative K. Now, this is my K value. I'm just going to put it in full times T, which is just X. And we want to find out what time will be 1 kilogram sugar remaining. So this is the equation for the amount of sugar remaining after 10 minutes. So we're trying to find what value of T gives us only 1 kilogram remaining. So I'm just going to let that equation equal 1, interactive and solve. So what time to be 1 sugar remaining? Now I'm not sure if the book answers to the whole number of arrows. If it's whole number of arrows, you round up. So it'll be 8 hours later. Or whether it goes 7 hours and you've got 0.212567 of an hour, if I times that by 60. So it'll be, if I were to convert to hours and minutes exactly, it'll be 7 hours and 13 minutes. So, like I said, it depends on how the book answers it. I'm just going to give you both answers, so you decide on whether to how to round it. So hopefully that helps.